Alright, so the fundamental theorem of algebra, formal definition, a polynomial of degree n has n complex zeros. Both are real and non-real. Some of these zeros may be repeated. So let me give you some examples. Alright, so I got a couple examples here. This is a polynomial, f of x equals x squared, and I drew that squiggly line because I'm not showing you the rest of it. I just want you to kind of see the parent function. Here's an example where this one is called the repeated. Does that make sense? Here's an example, f of x equals x minus 1 squared. Does that make sense? Because if it's both x minus 1 times x minus 1, you solve that, and you get x equals 1 and 1. Do you see how it's repeated? We've actually talked about that. That's the multiplicity, right? The bouncing off or the kissing. Alright, so went over that example. This example here, and all these examples where they cross the x-axis. What did I just say, class? So anything here in yellow, those are going to be our real solutions. Count with me. Ready, set, go. 1, 2. So this one has 2 real solutions. X equals 6, right? X equals -2. Those are real solutions. Here, how many real solutions do we have, class? I know you count at 1, but that's where they count this one as, like, they call it a double root. So you still have 2 real solutions. It's just the number's the same. Okay. Now we learned previously in leading coefficients that the power tells you how many max real x-intercepts. Okay, so it's telling us max 2. Max 2. But look at this one over here. Class, does this one cross the x-axis? No. So what color did I not use? I think I'm going to get that on the colors. What color do I have that I haven't used? I have a highlighter. Alright. So this distance off the x-axis, that is called a non-real solution, or a complex. Okay, so I have 2 zeros, but they're not crossing, right? So we call this 2 complex solutions. It's gonna have an imaginary number. It's gonna have I in it. Does that make sense? So, and then this graph here, we have max 3, but if I look at my graph, how many real zeros does it have? 1 real 0 solution. Okay, that means it has how many complex? 2 complex. Because 1 plus 2 gives me the 3 that I need. Remember, that's the max. That's the max. Okay. So the fundamental theorem of algebra basically says if it crosses the x-axis, it's going to be a real solution. And if it doesn't cross the x-axis, you're going to have things called non-real or complex solutions.